Okay, guys, welcome to our first video lecture for the remainder of this fall semester. So welcome, and I hope that this works for you guys, and please give me feedback as we move forward so I know that I am doing a good job. Okay, so we left off in section 6.2 for the midterm exam. 6.2, remember, was all about assigning probabilities to events. So we laid some of the groundwork in 6.1, learned about what events were and what the sample space was, and sort of started looking at the basics of assigning probability. And in this chapter, or sorry, this section, we are going into more detail. So as we learned in section 6.1, probability, the mathematics of probability, is a lot like the mathematics of sets. So a lot of the ideas that we picked up in chapter 5 we can use here. Now, if you remember, there was the inclusion-exclusion principle when we were learning about the set theory stuff. And remember what that said? That said that if we wanted to know the count of elements that are in the union of two subsets or two sets, then that was in general equal to the number of elements in the first set plus the number of elements in the second set minus the number of elements in the intersection. And remember that we subtracted 1 from the intersection because we had double counted the intersection. When we were counting the number of elements in E and counting the number of elements in F, we've counted the intersection twice, and so we have to take one of those away. So as I was saying, the mathematics of probability has a lot to do with, or can be derived from, a lot of the set ideas that we picked up in chapter 5. And so we have the same sort of idea for probability. If we have two events, and we're trying to calculate the probability of the two events, one of the two events happening, E or F, then this is equivalent to the probability of E occurring plus the probability of F occurring minus the probability of both events occurring. Okay. So just like what we did in sets, we have here for probability. Now, remember that with sets, if the intersection of the two sets was empty, meaning the two sets were disjoint, then the number of elements in the intersection was 0. And we have a similar sort of idea that happens with probability. So we talked about this already a little bit, but we have the notion of mutually exclusive sets or events. So mutually exclusive events are just like two sets that have nothing in common. So two events, E and F, are mutually exclusive if the probability of both events occurring simultaneously is 0. So mutually exclusive events are conceptually two events that cannot happen at the same time. It's physically impossible. It cannot both be Monday and Tuesday at the same time. It must be one or the other. So the probability of it being both Monday and Tuesday at the same time is 0. So if the two events are mutually exclusive, then their joint probability, the probability of both of them occurring, is 0. And so what that implies for the inclusion-exclusion principle is that the probability of one or the other event occurring, if both events are mutually exclusive, is simply the probability of the first event plus the probability of the second event, since we know that their joint probability is 0. So this is a special case of the inclusion-exclusion principle that we see right here, when the two events are mutually exclusive. So let's look at an example of how we would use this inclusion-exclusion principle. Suppose that we want to calculate the probability that when we roll a die, we get one of two things. We get either a 3 or an odd number. So let's look at the solution of this problem. So we look at the two events. The event E is we roll a 3, and event F will be rolling an odd number. Sorry about that. So the event E and the event F, we can determine, are not mutually exclusive. Both of these events can occur simultaneously. And that is because if we roll a 3, we are also at the same time rolling an odd number, because 3 is an odd number. So we cannot consider these two events mutually exclusive. If they're not mutually exclusive, then the probability of one or the other occurring must be equal to the probability of one occurring plus the probability of another occurring minus the joint probability, that is the probability of both of them occurring simultaneously. So let's figure out each of these three probabilities. Okay, so the probability of rolling a 3 is determined by finding out the number of ways of rolling a 3 versus the total number of ways of rolling a die, or the total number of results that we can get. So a die has 6 sides, each side with a separate number on it. One of those numbers is 3. So there's only one way to roll a 3. There are 6 possibilities. Therefore, the probability of rolling a 3 is 1 out of 6. The probability of rolling an odd number is equal to the number of ways of rolling an odd number versus the number of ways of rolling any number. So the total number of possibilities, again, which in this case is going to be 6 again. The total number of ways of rolling an odd number would be 3. Why? Because either we can roll a 1, a 3, or a 5. So there are 3 ways of rolling an odd number. We always want to reduce the probabilities. So the probability of rolling an odd number is 1/2. Now we need to figure out what is the joint probability. What is probability of both occurring simultaneously? So again, we want to figure out what the probability of both occurring is, or really what the number of ways of both getting a 3 and an odd number versus the number of ways of rolling a die. So there's exactly one way to roll a 3 that is also an odd number, and there are 6 total ways of rolling a die. So the probability of rolling a 3 and an odd number is 1/6 again. Finally, we can put this all together and calculate the probability of rolling a 3 or rolling an odd number, which is going to be 1/6 plus 1/2 minus 1/6, which we see is going to equal 1/2, because this and this cancel out. Okay, the last thing that you're likely to see in section 6.2 is probability phrased in terms of what are called odds. So we want to know what odds are and how to convert odds to probabilities. So odds, you usually have heard this said usually in the context of gambling, that the odds of a certain outcome are, say, 2 to 1 or 2 to 3 or something like that. You usually hear it phrased in that way. So odds are like ratios, and we usually write them down as some number to some number. So the odds of some event occurring are A to B. So this is read A to B. Now, how do odds work? What is this A to B? A is the basically the probability of the event occurring. In some sense, it's related to the probability of the event occurring. It's really the number of ways that the event, and here we're going to call it E, can occur. So it's not a probability per se, but it's related to this probability. So it's really, A is really the number of ways of a certain event occurring, and B is the number of ways that the event cannot occur. Okay, so when you're placing a bet and the odds are 2 to 1, that means there's 2 ways that you can win and 1 way that you will lose. So those are pretty good odds. Bad odds would say be 1 to 2 or 1 to 3. So there's 1 way of you winning and 3 ways of you losing. So this is how odds work. Now you'll see examples of probabilities phrased in terms of odds. Again, so the example would be the odds of rolling a 3, if we're rolling a die again, like we always like to do with probability, the odds of rolling a 3 are 1 to 5. So there's 1 way to roll a 3 and 5 ways to not roll a 3. So these are your odds. Now we know that the probability of rolling a 3 is 1 to 1/6. So there's 1 way to roll a 3 and 6 ways, 6 possible outcomes. So how do the odds of rolling a 3 relate to the probability of rolling a 3? So in general, if we have odds A to B for an event occurring, so the odds of an event E occurring are A to B, then this is equivalent to the probability of E occurring being A over A plus B. So this is in general how we translate odds into probabilities. So we can see with this example up here that the odds of rolling a 3 are 1 to 5. The probability of rolling a 3 is 1 to 1 plus 5, which is 1/6. So we could be going in the other direction as well. How do we translate probabilities into odds? So suppose we know what the probability of a certain event occurring, suppose we know what the probability of a certain event occurring is, we want to know what the odds are. Okay, so we know what the probability of a certain event E is, and we're going to call that probability P. If we want to figure out how to translate this probability into odds, then what we do is we form a fraction, P over 1 minus P, which really is the probability of P occurring, or sorry, the probability of E occurring versus the probability of E not occurring, which is 1 minus P. So if we form this particular fraction and then reduce it, so reduce it in terms of fractions. So you know what reduction means in this context. If we reduce that fraction, then it will reduce to some other fraction, A over B. And this A over B, these two numbers, tell you what the odds of event E occurring are. So that finally implies that the odds are A to B. So to recap, if we know what the probability of E is, it's P, and we want to figure out what the odds are, then we take the probability of E over the probability of E not occurring, which is 1 minus P. We reduce, and we get a new fraction, which is A over B, the reduced fraction. The numerator is the number of ways of E occurring. The denominator are the number of ways of E not occurring. And this tells you what the odds are, A to B. Okay, so let's look at an example. We know what the probability of rolling a 3 is. It is 1/6. So we want to figure out what the odds are. So we start by forming a fraction, which is going to be 1/6 over 1 minus 1/6. Okay, so this is the P over 1 minus P. We then have to simplify this. So we've got 1/6 in the numerator and 1 minus 1/6, which is 5/6. Then to reduce this fraction, we do the keep, change, flip trick. We keep the numerator, change division to multiplication, and flip the denominator. So that's 1/6 times 6 over 5. So if we continue in this chain, then we have a 6 in the denominator and a 6 in the numerator. So these two cancel out, leaving me with 1 over 5. So once the fraction is reduced, then we can use it to determine the odds. And this implies that the odds of rolling a 3 are 1 to 5.